Morning, sir. Kindly give me cue if we can start already.
Yeah, we'll start.
Okay. Okay. Hello, everyone, and welcome to the technical session 5C in the virtual room C of the International Conference on Machine and Computing Technologies for Sustainable Development, or MCT4SD. My name is Julius Sareno from the Technological University of the Philippines, and with me is Professor Hegde, sir.
Yes,
And we are your digital session chair for today. So we have a really exciting lineup of presentations focusing on innovative applications of machine learning and computing technologies for sustainable development. Our session will explore topics ranging from AI in education to optimizing data retrieval and anomaly detection, all the way to sustainable transportation solutions. Uh, our presenters,
Um,
yes,
I'm
yes, ma'am.
sorry, just give me a second.
Mhm.
Uh, Hi guys. Hi Dharmik, has the session been introduced and all? Has it started? Can someone just reply? Has the introductions and everything been done?
yes.
All right.
Mhm.
I think we can start the presentations.
Okay,
Sir, I'm sorry, sir, Julius, sir. Can you just wait for a minute?
okay.
I'll
Sorry.
just commence the session. Give me 2 minutes. I have just
Sure, sure.
joined. There was some network error. I'll just commence the session officially and then we can start. Is that
Yeah,
okay?
yeah, sure,
Okay,
sure.
thank
All
you.
right. Thank you so much. Just give me a moment, guys. I'm presenting the screen. Is my screen visible?
Yes,
Yes.
All right. Um, yes. Good morning, everyone.
Good morning.
good morning.
Um, yes. Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 5C. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it's my great pleasure to welcome you all to the International Conference on Machine and Computing Technologies for Sustainable Development, MCT 4SD 2025, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held day before yesterday in Manila, Philippines, and the virtual event is being held through Zoom today and yesterday, 12th and 13th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we will have 8 presentations. Each presenter will be given 12 minutes for the presentations, please note that, and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce the chairs for this session. Professor Julius Serrano, welcome, sir, and Professor Nishya
Okay,
Kumar Hegde. Welcome, sir.
Thank you.
thank you.
Uh, Professor Julius Serrano is an associate professor and the director of University Information Technology Center at Technological University of Philippines, Ermita, Manila. He specializes in web development, Java programming, software programming, database programming, and computer programming. With a strong technical background and leadership in IT services, Professor Serrano is committed to advancing digital capabilities and fostering innovation within the university community. Thank you so much, sir, for joining us. And I request you to share a few words of wisdom. before we start the session?
I have already shared my video, and hello everyone. Nice to be here, and thank you.
Okay, I'm sorry I missed that. Thank you so much for joining us. Um, Also, Professor Nishchay Kumar is an associate professor at Canara Engineering College, Karnataka, India. His academic and research contributions focus primarily on wireless sensor networks, with a strong emphasis on developing solutions that are both practically relevant and socially impactful. He remains committed to advancing research that addresses real world challenges while enriching the learning experience of his students. Welcome so much, sir. And if you could also share a few words of encouragement before we commence the session officially.
Yeah, surely. Thank you, first of all. I'm really looking forward for technically strong sessions, which would provoke me to get into deeper depth into the research. I'm waiting for it. Thank you.
Thank you, sir, for joining us. And now, without further ado, let's start with today's session. First up, I would like to request Sir Faizan Fadlullah to kindly present his paper titled AI Enhanced Readiness, Assessing Customer Experience Management in Indonesian MSMEs through the Technology Readiness Index. Do we have you here with us, sir? Is anyone from the team present? All right, since no one is responding, we'll be moving forward to the next participant. I request Ma'am Mary Jeza to kindly present her paper titled A Fuzzy Inference System for Academic Program Recommendation, a Mamdani Model and its Validation. Do we have you here with us, ma'am?
Yes, ma'am. Good morning.
Good morning, ma'am.
Thank you so much. I'll just share my slide. Thank you so much.
Yes. Yes, please. Yes, your screen is visible. You may start. Ma'am, your mic is mute, I guess.
Okay, good morning, everyone. I'm Mary Jessa Sabalia Marine. So I will be presenting our work on using fuzzy logic to guide students in choosing academic programs with the title of A Fuzzy Inference System for Academic Program Recommendation, Mamdani Model and its Validation. So this was a collaborative effort of Ricardo A. Catanghal Jr., Edward Louis M. Marine, and yours truly from the University of Antique, Ceballos, Antique. Um, Choosing an academic program is a complex subjective decision for students. Program choice is one of the most difficult and subjective decisions students face. So many factors influence this choice, including aptitude, interest, and external pressures. So traditional advising models often reduce decisions to binary thresholds, such as pass or fail, qualified or not qualified. So this oversimplification fails to capture the complexity of student performance. Student skills and aptitudes exist on a spectrum, not in a rigid category. So a student may be moderately strong in one area and highly proficient in another, which binary modes cannot reflect. In reality, student abilities exist on a spectrum rather than fixed categories. Because of this complexity, advising requires a system that can handle ambiguity. Therefore, there is a need of more nuanced, human-like guidance framework that is necessary to provide fairer, more accurate recommendations. Now that I have explained the motivation of the study, let's move on to the objectives. So the objectives of the study are the following. The primary goal of the study is to develop a Mamdani type fuzzy inference system for academic program recommendation that can model the ambiguity of student decision making. This system provides a structured, mathematically grounded framework for academic advising. The second goal is for the system to incorporate entrance exam scores, general weighted average, and discipline specific aptitude scores in software, networking, and data management. So these inputs are translated into a fuzzy linguistic variables to capture the spectrum of student abilities. The third goal is for this model to be evaluated through expert evaluation against established software metrics and historical student data. For the methodology, we followed the design and development research methodology with rapid application development phases, ensuring iterative prototyping and feedback. The case study was conducted in the College of Computer Studies of University of Antique. For the fuzzy inference system architecture, so the R system takes 5 crisp inputs, the entrance exam, general weighted average, and 3 discipline specific aptitude scores, which are composed of software, networking, and data management aptitude. So it produces 1 crisp output, which is a program recommendation score. So the process follows the standard fuzzy logic pipeline, classification, inference, aggregation, and defuzzification. This ensures that vague inputs are transformed into actionable recommendations. For the membership, we use triangular membership functions for computational efficiency and clarity. So for example, in the exam score of 72, the 72 might partially belong to both medium and high categories. So the overlapping allows the system to handle borderline cases gracefully, unlike binary cutoffs. For the rule base, the system operates on the comprehensive rule base consisting of 81 fuzzy rules. These rules define how combination of input variables map to recommendation scores. So rather than applying all inputs uniformly, the system uses a program-centric approach. So for the computer science, program-specific weighting, for the computer science track, the rules heavily weight on software aptitude and data aptitude with academic scores as filters. So meanwhile, for the IT or information technology, networking aptitude and software aptitude are prioritized. For the information systems, the rules maintained a balanced emphasis across aptitude, scores, and academic metrics like entrance exam and general weighted average. So this structure mirrors how human advisors tailor recommendations based on program requirements. So it ensures that recommendations are aligned with the distinct competency profiles of each computing disciplines. So we validated the system against 50 student records with expert verified recommendations. The results were strong. For the accuracy, we have 94%, precision 92%, recall is 96%, and F1 score of 94%. Experts also rated the system highly on consistency, correctness, and traceability with a mean score of 4.86 out of 5. The Mamdani, for our conclusion and implications so far for the study, the Mamdani fuzzy inference system has been validated through both expert evaluation and student data, proving its reliability as a decision support tool. So its mathematical rigor ensures consistent and accurate recommendations. So unlike traditional models, the system recognizes that student abilities exist on a spectrum. By using fuzzy sets and overlapping membership functions, it reflects the complexity and real-world academic advising. So the framework is not limited to computing disciplines or a single institution. So it can be also adapted to other academic fields and universities, offering a scalable solution for student guidance. Expanding the system to cover more programs will increase its utility. Integrating machine learning techniques can further refine recommendations combining fuzzy logic's interpretability with machine learning's predictive power. So in conclusion, fuzzy logic provides a reliable, nuanced tool for academic advising. It's adaptable and it can be extended further. So thank you so much, everyone.
Thank you, ma'am, for your wonderful presentation. Are there any questions?
Yeah, it was a nice presentation, madam. And I would like to know, have you realized this already implemented?
No, sir. We just performed a sample only, sir. But this is ready for deployment.
Okay. Any neural network concept is involved in this? Sorry, I'm not able to hear you.
I'm sorry, sir. There's no integration of neural network yet, yes, sir.
It's totally fuzzy logic based. Yeah.
Yes, sir. Yes, sir.
Okay. Thank you, madam. It's good concept.
Thank you so much, sir.
Mhm. And Ma'am Sabala, morning.
Yes, sir.
How do you plan to incorporate student preferences and feedback into the fuzzy inference system in the future iterations?
Um, Planning, sir, if there will be in the future iterations, we're planning to integrate it machine learning so that it will automatically um, give a suggestion based on the inputs given by the advisors. No? So wherein it will automatically produce a recommendations for the programs based on the inputs given by the advisors.
So for the Mandami model in the context, how might other fuzzy inference system compare with the
Well,
limitations of this Mandami model?
okay. So Ma'am Dani model actually we choose this because this is we find this more interpretable which aligns well with human reasoning. So it allows us to use linguistic terms and triangular membership functions, which is easier for academic advisors to understand.
Okay. Okay. Thank you.
You're
Thank you.
welcome, sir. Thank you so
Thank you.
much.
Thank you so much, ma'am. Thank you,
You're
sir.
welcome. Thank you.
Can you? All right. Yes. Moving forward, I would like to request Ma'am Celeste Marsado to kindly present a paper titled AI Pedagogy Competency Framework for Filipino Science Teachers. Do we have you here with us, ma'am?
Yes, good morning. I'm ready to present. May I share my slide, please?
Yes, ma'am. Your screen is visible.
Yes, good.
Yes, you may start.
Good morning to our moderator, Dr. Priyanshi Goyal. Also, good morning to our session chairs, Dr. Julius Sareno and uh, Dr. Dr. Professor Nishai Kumar Hegde. Good morning to everyone. So I'm here to present to you my research entitled the AI, Artificial Intelligence Pedagogy Competency Framework for Filipino Science Teachers. Um, so yeah. So I have conducted this study primarily because when the United Nations Educational, Scientific, and Cultural Organization, or the UNESCO, released the AI competency framework for teachers, I was wondering if our teachers, specifically science teachers, are what is their view or what they think is the acceptability or what they think would be the effect of this AI competency framework that the UNESCO released, because definitely this will be cascaded, or this will be the framework that will be adopted by the relevant um, agency, which is the Commission on Higher Education here in the Philippines. So um, I have we also know that based on that report, the UNESCO mentioned that only 7 countries had fully developed the AI competency framework or professional development program for science teachers. And I'm really very curious about science teachers in particular, because we know that in science, we really need to develop computer-aided instructional materials so that the students will not just imagine the scientific processes, but will really clearly understand the process through the use of AI and AI-assisted instruction. So the AI competency framework for teachers likewise addresses that gap, or that kind of situation or issue wherein only a few countries have shown fully developed AI competency frameworks among their teachers. So it was last a few months ago when one of our commissioners had a very bold um, pronouncement about the need for artificial intelligence to really aid to learning in the context of Philippine higher education. And we know that the Commission on Higher Education is really working very hard to capacitate or to have our higher educations embrace or integrate artificial intelligence with this bold move of our commissioner, Dr. Ethel Agnes Valenzuela. So we are very positive that AI integration will really find its way in the very classrooms of our Philippine education. So the study aims to develop, contextualize, and validate an AI pedagogy framework for Filipino science teachers in select state universities here in the Philippines, aligned with the dimensions of the said UNESCO framework. I hope that the study will be able to fill the critical gap in defining AI pedagogy competencies, specifically for Filipino science teachers, which we know are not being addressed by current or existing global and national frameworks. So I have adopted a qualitative exploratory design to systematically contextualize and develop the progression of AI pedagogy framework tailored for Filipino science teachers in the higher education institutions, both public and private here in the Philippines. And the study employed an in-depth interview-based focus group discussion, a qualitative approach to explore Filipino educators' perceptions, experiences, and expectations regarding AI integrated pedagogy. So the AI integrated pedagogy, which is based on the UNESCO AI competency framework, is composed of 5 domains or dimensions. The first one is human-centered or values-driven mindset. So I just selected nice responses from 2 of the participants. So regarding human-centered and values-driven mindset, they have those are responses. As a science teacher, I anchor my instruction on our national values and that AI must respect those principles, which is coded PROGAD or MACADIOS, value-based integration. And another participant mentioned that if AI forgets our culture, it's not worth using. So we must embed the national identity in the use of artificial intelligence, which is coded for pro-country or makabansa and also for cultural identity. So the introduction of AI into Philippine science education is guided by firm, human-centered, and values-driven mindset of our Filipino teachers, with the technology set to support and not replace vital human aspects. For the second dimension, the evidence leads directly to the need to go beyond more on AI adoption to a model of scalable, inclusive innovation. The evidence also suggests a pedagogical shift design, which is necessary, wherein the AI tools need to be designed for differentiation and cultural sensitivity, and not just for generic use. So one participant mentioned mapping student tech profiles helped me realize how unequal access is. I modified my AI tasks accordingly. So codes are used to thematic codes are used uh, to be able to classify or to organize the responses of the participants. So let's go to the third domain, which is contextual relevance. Um, the evidence overwhelmingly points towards the need for real implementation success in relation to AI to be reliant on rigid compliance with the curriculum, which calls for policy requirement that develops adhere to the curriculum over permitting AI to be a force of disruption. And some of the participants mentioned um, about in teaching biodiversity, this is the teacher that handles biology class or environmental science class. So they would like to have the AI be used in the biodiversity, especially when students analyze the Philippine ecosystem, which is very unique as compared to the ecosystems of other regions. Another for participant 8, he mentioned that we need tools to respond to our setting, not using the setting of the other country. It should fit our barangay's context, which is the smallest unit of political system in the Philippines. So the immediate environment should be the context of the development of the AI tools that will be used according to the participant. And for lifelong learning, one participant mentioned having peer mentoring helped me understand AI better than any training workshop. And all AI learning should be ongoing. I join webinars regularly to stay updated. So for the final domain, which is ethical responsibility, it highlights that um, it highlights that teachers should move from being passive users to AI to being actively engaged as custodians of safe and equitable AI practices. So the participants are very much aware of their ethical responsibility. One participant mentioned that policies on AI should exist in every school and that we need safeguards. Another participant is worried about data leaks, and we should teach students to protect their identities when using AI platforms. So for the conclusion, a strong consensus among our Filipino educators on the need for a human-centered and culturally relevant approach to AI integration. The resultant five-dimensional or five-domain model grounded in human-centered mindset, equity, and inclusivity, contextual relevance, lifelong learning, and ethical responsibility not only reiterates the teacher's position as a guardian of cultural values and ethical integrity, but also gives a clear acquire, deepen, create trajectory of professional development. Primary among these institutionalization measures include that the educators are encouraged to incorporate its levels to their continual professional development plans and participate in collaborative learning networks with higher education institutions and the national policy agency policy requiring the embedding of framework into faculty development, investing in low bandwidth inclusive infrastructure, and explicitly including teachers in policy governance in order to make AI implementation culturally responsive, ethically just, and sustainably equitable. So that's all. May I
Thank you, ma'am.
have your questions?
Thank you, ma'am. Ma'am Dr. Professor Celeste Mercado, for sharing your work on the AI pedagogy competency framework for Filipino science teachers. Thank you, ma'am. And this is crucial for effective AI integration in education. I have this suggestion. May also consider including specific examples of how teachers can demonstrate its competency in a classroom setting. And I have two questions.
Yes,
My
sir.
yeah. My first question is how can this framework be adapted for teachers in other subject areas or educational levels? And the next one is what support and resources will be necessary to help teachers develop these competencies effectively?
Thank you, sir, for your question. I think UNESCO released this AI competency framework. It's more on a generic framework that is applicable regardless of the subject or regardless of the area that the teacher is handling. So if this framework applies to science teachers, I believe it also applies to mathematics teachers or social science teachers. So it's a generic framework that I think is applicable to any kind of teacher, because UNESCO said just teachers. It's not really a framework for science teachers, but it's a generic kind of a framework. So for your second question, I think it's really imperative and it's really urgent that the Commission on Higher Education will release its memorandum order on the policy standards on the use of artificial intelligence, and would compel our higher education institutions to develop their own AI policy. Only then can the higher education institutions will really have um, solid and well-defined pathway in terms on how they make use of AI in all levels of instructional activities, from the lesson planning, from the assessment, from the learning activities. There has to really be a policy, and well, some HEIs have already their own policy, even without the policy or the guideline from CHED. So we're glad that some HEIs are already equipped or are already having their own AI policies.
Thank you, Ma'am Celeste, for sharing your work, and we look forward for your future endeavors. Thank you.
Thank you.
Madam, I have one question. Basically, I being the teacher to my students on the first, I tell them how I evaluate their answer scripts, and probably that gives them a mindset to put their answer in the answer scripts. Now, my question to you is how Filipino teachers are different from traditional teachers. You take any country, because the title says for Filipino teachers. So I would like to know that.
Pardon, sir, how Filipino teachers are different from
Traditional teachers, conventional teachers.
traditional teachers?
Yeah.
Um, well, I must say that Filipino teachers are creative and resourceful, though we have limited budget for our education, because especially for public institutions or public schools, we really have a very limited budget. But our teachers are very resourceful and very creative in such a way that they can maximize whatever locally available resources they have. And by trying to partner with private and strengthen the PPP or the private public partnership, they can get donations of some softwares or some available technological tech materials from their stakeholders, such as the alumni, the private industries, and other stakeholders. So they are very resourceful despite the limited budget.
Yeah. And can this model be adapted to other country teachers? If so, is this model flexible?
Yes, being very flexible as well.
Okay, thank you.
Thank you.
Thank you, Ma'am.
Thank you, ma'am. Thank you, sir. Moving forward, I would like to request Ma'am Supriya Narad to kindly present her paper titled AI-Driven Optimization, Fast and Scalable Data Retrieval in Big Data Storage. Do we have you here with us, ma'am? Is anyone else from the team present? Since there is no response, we will be moving forward. I request Ma'am Chaitra Ravi to kindly present a paper titled Anomaly Detection Using Deep Learning and Generative AI. Do we have you here with us, ma'am?
Good morning, one and all.
Good morning, ma'am. Yeah, you can share your screen now.
Yes. Just give me a minute.
Yeah, sure. Yes, ma'am, your screen is visible.
Yes.
Can you put it in presentation mode?
Yes, 1 minute.
Yeah. Yes, it's visible. You may start.
Good morning. Thank you for giving me an opportunity to present my paper. So my paper, I am Dr. Chaitra Ravi. I'm an assistant professor at BMS College of Engineering. And my paper is all about anomaly detection using deep learning and generative AI. So,
Madam, excuse me.
yes, sir.
Can you switch on your camera?
So 1 minute. I am so sorry.
Yeah, it's okay. It's okay.
I'm so sorry, sir.
It's
So
okay.
the presentation agenda is all about the introduction, problem statement, the objectives, the research findings, the methodologies that I've used, and the research findings, and the final conclusion. So to begin with, the introduction. The introduction is all about the anomaly detection here. Be it any domain today, you name the domain, and there are certain anomalies which are detected. So, to eradicate the anomaly in the very initial stage, we thought we'll build up a model which is feasible, and we are also integrating two different models to eradicate the anomaly detection in the early stage, so that moving further, the model is well trained according to whatsoever technologies that we use, and based on that the performance or the other matrices which is to be evaluated is being evaluated. So currently, since we are focusing on the anomaly here, finding patterns that matches the exact output has become a tedious job today in any domain. So to overcome that, sample of models we worked on, and we thought we will come up with one particular model integrating with the federated model to overcome the data fitting issues, or be it the other tedious issues that's seen today's world. To the anomaly detection here, patterns are whatever the predictions are done, we are doing it with the data set which is already present. That is, we are using the MSIST data set here. So using that, we have used MO, that is multi-objectional artificial bee colony. Along with that, we are using a federated learning. So by integrating these two models, we are checking what is the best possibility to find out the anomaly detection. Along with that, we are also looking into the practical applications, like eradicating the detection of intrusions, or identifying the fraud detections or system when it comes to your medical field, the health monitoring, or any other anomaly detections. We are trying to eradicate it. But with increasing complexity of the data, the traditional models which was present, it failed to capture the rare and specific patterns when it has been identified. To overcome that, certain deep learning models and certain Gen AI models is being integrated in this present research. So the current problem statement here we have is, as I told you, the current anomaly detection suffers from a very severe data imbalance problem, which is also limited to certain anomalies. So when it comes to the global anomalies, we were not able to find the global anomalies using the traditional methods which was already present. So to overcome that, we thought we will integrate two different models and then find out the anomalies. And second problem which we found out was there was multiple overfitting issues because of the huge data set that we've been giving. So to overcome the overfitting issues and also to avoid the privacy risk which is present in the centralized system and also for the non-IID distributions, we thought this model is better. And the third thing is the intrusion detection systems in the IoT environment, especially due to the noisy and imbalanced data, that was also another problem which was recognized. And finally, since the data sets which we were identified was not labeled, so there were multiple unlabeled data as well, because of which, again, the detection was a huge problem. So because of which the detection is also difficult. So to overcome all this, we have proposed a model. So the main objective of this paper is to generate a Gen AI based technique to overcome the overfitting and to improve the detection rate, and also to resolve the data imbalance issues. The third thing is here we are also proposing a classifier along with the adversarial network, and as I told you, we are integrating federated learning with the MOABC, that is the artificial beat colony, to improvise the accuracy of anomaly detection. Along with this, it presents a FedGAN IDS network, Federated Anomaly Detection Framework. It is integrated with the GenAI adversarial network, so that irrespective of any domain, we will be able to find out the anomaly here. So the methodology here, as I told you, we are integrating two different models. One, the deep learning model, that is the federated learning, which we are integrating along with the bidirectional GANs. So what does this bidirectional GANs do is here we are actually creating images. So synthetic images are being created so that the model is having its own images to compare it with the federated learning. So what does this federated learning actually do here is, I told you there are multiple overfitting issues with the data. So when I tell the multiple overfitting issues, it can be either the optimization, or it can be either the noisy data, or any kind of disturbance. Every single cause that is being done, it is overcome by this particular models. So by integrating these two models, we found out that the classification is also way more better, and for the synthesis of any kind of images, this particular model is also giving us better results. So proposed architecture framework, it's all about this particular architecture. Here we are actually filtering the basic data that we are taking, and among that basic data which has been taken, we have selected certain features. Now I told you anomaly basically depends on multiple features. So not all features can be taken, and not all features can be evaluated on one particular model. So based on the model that we have selected and based on the features that we have selected, then it is fed to the bidirectional GAN. So what does this bidirectional GAN do here is, as I told you, the synthetic images are also created here. So the encoder and the decoder part will take care of what particular feature is to be selected. So based on the selected feature, we are actually dividing the true or false images. Like, let's say we have an image, and that particular image has to be selected. One particular feature from that image has to be selected, and using that feature, we are giving it, or the input is being given to the GAN model, and the GAN model, based on that input, it will create further more images, and it will identify the anomaly. So once the anomaly is identified, whatever images that has got the anomaly will be then fed into the multi-objectional artificial bee colony. So this bee colony, if at all there is any overfitting issues, then that will be eradicated. So once it is eradicated, finally the classified images, if the image has been detected as an anomaly, or if it is not detected as an anomaly, finally the images are being sent out as an output. So this is the complete architecture. And moving further, this will be the flowchart. As I told you, initially the collection of data has been done, and pre-processing. We are doing few pre-processing here, the normalization of images, be it and any color corrections, or any sort of noisy data, or any sort of overfitting issues. That's been done in the pre-processing stage. And next stage, feature selection. So why feature selection? Any animal needs certain features. So based on that features, we'll be identifying if that particular image is animally detected or not. So that's been done. So once that is been done, then classification is done. So in this feature detection, feature extraction and selection, we are using the GANs to actually create synthetic images. So based on that synthetic images, then finally on the given features, we'll be identifying the anomaly, and finally the optimization of data is done. And once the data is optimized and we get a final classification, the performance is evaluated on based on the other matrices that has been present. So you can ask me why this particular model, how is it even helping today's society? So if at all I have to answer this, the current research findings, what we have done here is by integrating FedGAN and the MOABC colony, the performance and the accuracy rate is too high, which the traditional models was lacking. And as I told you, there are minority classes which are present in anomaly detection. So those minority classes have been overcome by these GAN models. And by using the artificial bee colony, we are also reducing the computational computation, and the system also becomes faster. So these are the research findings that we have done, and these are different comparison matrices which I've done using different models. So if you can see, I've used certain SVMs and also the auto decoders, and I've used the sanded GANs. But when it is the federated GAN along with the MO ABC model, you can see the performance, the precision rate is also high. And if you can see the other matrices, like let's say the recall matrix, again, the model shows me a higher rate. And finally, the F1 score also gives me a better score in this particular model. So these are the comparison with the different models and different matrices that I've used. So when it is compared with different model and the matrices, the performance or the precision, or be it the recall rate, it gives me better rates, or the rates are, if at all the false rate is C, the false rate is also a little bit low compared to any other model. So I feel this particular model is better fit. And this, whatever research we have done, it's not yet deployed on the real-time data. So we have just done a survey, and this particular survey showed us really good results. So we thought we'll do the deployment for upcoming real-time images based on automobile industry or any medical data that we get. So these are the results. So it showed a really great improvement. And coming to the conclusion, hence these two models are being integrated for better anomaly detection and classification. And future work, as I told you, it can be deployed on any edge devices. So when I tell edge devices, we can also try implementing in drones as well as satellite images, because we find there's a lot of complications with the
Gentle 2
satellite.
minutes reminder.
Yeah, there's a lot of satellite images which is facing this anomaly detection. So to overcome all this, we can be used it for future work. So any further questions, I'm open for it. So thank you so much.
Madam, I have a question for you. That is,
Yes, sir.
have you realized this proposal implemented?
It's not yet implemented on real time. So we have just come out with the model, and since the model showed us the better performance, so we thought we will be implementing on autonomous data and medical data.
Okay. Whether you have simulated this?
We have used the MN IST dataset for it, and for
You have
the
simulated this?
yes, sir, but not with the real time data.
Not real time. The data set, whatever you have got,
Yes.
simulated. So whether this includes the overall implementation includes neural network?
Not exactly neural networks. So partial, I'm using the GANs here. By using GANs, the synthetic images I'm creating it, and in that one I have decoders part, where rate is also identified. Along with that, I'm also using the artificial bee colony for that.
Okay, and I want to know what is that imbalanced data? Can you give an example for?
So when Yes, when I'm taking a huge data, what happens is the data set will be, it doesn't have a synchronous data, or it doesn't have a semantic data. So there will be some kind of disturbances in the data. So that particular disturbance, or when it comes to any sort of quality, so that itself is the class imbalance thing.
Last question, that is, data can be here IPv4 based or IPv6 based.
So it can be either of it, because this is a generic one which I have taken.
Okay, thank you.
Thank you, sir.
Thank you, Ms. Chaitra Ravi, for your presentation. Uh, my suggestion is it would be very interesting to see how this approach performs on different types of data sets, particularly those with imbalanced classes. And I have one question. What specific deep learning and generative AI techniques did you find most effective for anomaly detection, and why?
The most effective one, which I was able to find here, is the FedGANs, Federated Learning, along with the multi-objective artificial bee colony that I've integrated. Why? Because integrating two different models gave me better performance, and the accuracy was more. So I thought integration of these two models would be greater performance. And when it comes to the cost or the other perspectives, it's better. So these two are the models that I'm proposing as of now.
Okay, thank you.
Thank
Thank
you.
you, Ms. Ravi. Thank you.
Thank you so much, ma'am. Thank you,
Thank
sir.
you.
Can you please stop presenting?
Yeah.
Yes. Moving forward, I would like to request Sir Yash Jaiswal to kindly present his paper titled Large Language Models versus Classic Metrics for Software Defect Prediction, a comparative study on the JDT dataset. Do we have you here with us, sir?
Yes, yes, ma'am, I'm here.
All right. I will
I
stop
just,
sharing my screen. Yes. Can you please share your screen and can you turn on your camera? Your screen is visible?
yes, ma'am, I'll turn on my camera.
Yeah.
Am I visible to everybody?
Yes, you're visible and your screen is also visible. You may start.
Okay, ma'am. Okay, good morning to everyone. Today, I, on behalf of my group members, would like to present a brief on my paper, Large Language Model versus Classical Metrics for Software Defect Prediction, a comparative study on the JDT dataset. Before we move on to our presentation, I would like to list all the agendas that we have for today. We'll begin with the introduction to our paper, followed by the motivation that led us to write this paper, literature review, and the following that you can see on the screen. Introduction. So in the modern software development environment, where modern methods like RAD, Agile, Lean, and Kanban, and different software methodologies are aiming to develop the software at a very faster rate and develop them in an incremental order. The software defects becomes quite the software defect introduction to our system becomes quite common, and to reduce this and most of these systems or most of the application that we're delivering is being used in real time, so to stop the errors from being to stop a lot of errors to being introduced to our production is becomes very important. This software defect prediction has become a very area of major focus in the software development area. So the motivation behind writing this paper was I was going through these different papers and I could find like two methods were being used in this area. One was classic software model that were that used the structural insights to find the defects, whereas the Large language models were being used to capture deeper semantic patterns. If you see the recent studies on in this area, like in 2018 or 2019 papers, various type of metrics such as CK metrics, OO metrics, class-based metrics were being used, whether metrics like line of codes, WMC, number of try block methods were being used, and classical machine learning models like XGBoost or random forest were being used in this area. But with the modern LLM, with the modern LLMs that came, then we started using these models like codebird, graph codebird in this area to create the embeddings and capture the deeper semantic logical flows, data flows of the different code files, and then find and then use them to predict the software defect. Yes, we like when we were studying most of these studies, what we found is like there was not direct comparison between these two different methods, or like or many places the file level or the function level defect prediction techniques were being used, but at the commit level, where the actual evolution was taking place, there was uh, not many studies that had been conducted. Also, there was not no direct comparison or the hybrid approach that was being incorporated. Just in our experimentation, we tried compare the different approaches performances, as well as see how combining them could give us a better result. So if we go to the contribution of our paper, we have done a systematic comparison of multiple feature categories that included classical metrics as well as deep embeddings. We generated our own novel data set based on the GitHub GDT GitHub repository, and we created a data set that could be used both for classical as well as embedding based models. Before we move on to the model architecture, I would like to discuss the data set which and how did we create the data set. So we actually came across a metadata file that had the different commit IDs and the files that and information about the files that were changed, and when the dates and it had different kind of metadata about the different commits. We use those commits to actually extract the real files from the JDT GitHub repository, and we stored two files in different folders, before folders and after folders. The basic intuition was that the file before the commit, it was a defected file, so it was kept in the before folder, and the file once after commit, it was being when it was fixed, so we kept it into after file that was a correct or clean file. Once the files were extracted, we used Lizard and different Python libraries to generate static metrics, CK metrics, O metrics, and different kind of metrics. Followed by which we implied codebird model, graph codebird, code T5, which were freeze and they were used to generate this embeddings, and then the final hybrid data set was made, which had uh, total 14,000 commit level instances and 27,972 hybrid rows. Now we'll move to the model architecture. We started with the baseline models. Baseline models. Random forest was used to train our model on the metric based models, so classical metric based model. Uh, and embedding based model used a multi-layer perceptron, which was trained on PCA reduced LLM embeddings, because it was initially 736 embedding, which was reduced to 128 embeddings. Following which we used a hybrid stacking ensemble model. That was our proposed model. We took two separate models, random forest classifier, which was being trained on the classic metrics, and the MLP model, which was being trained on the embeddings. And based on the predictions from both the models, we used tracking symbol model as metal light GBM, which was used to combine both the results and then give us the final prediction whether the file was buggy or clean. For our study, we have used 5 different metrics to evaluate the performances, and the data set was split into training test using 85%. 85% was used as train and 50% was used test data set, and we used the matrices such as ROC, AUC, accuracy, precision, recall, and F1. For our result, if we can see that the metric-based model was able to give the ROCUC of 0.8812, while the embedding model only gave 0.7735. But when we use a hybrid approach, it was able to give better results of 0.8987. Even if we could see for F1 scores also, the hybrid approach performed better. If we see the future work for our paper, we have tested this model. We have tested our model on only a single dataset, that is JDT dataset, which is based on Java. So we haven't done a cross-project we haven't identified like how it performs on the cross-project dataset as well as cross-language, maybe like on different languages like Python or Go. Also, the models which were used to generate the embeddings initially for the raw extracted files, we had not fine-tuned the model due to the resource constraint, and the models which were used to generate the embedding, those were frozen. So we can doing that will give us clearly better results. We can incorporate graph neural networks as well as advanced transformer architectures, as well as we can explore beyond MLP. We can explore better deep learning models such as better deep learning models. With with this, I would like to conclude, and I'll be happy to hear the views from the panel.
Any inclusion of explainable AI in your work, in your proposal?
No, so we were not able to do any inclusion of the explainable AI. However, we did use the RF, and we tried to see the which features were important for our studies, and we found out that the LOC was one of the most important factor that was influencing the defect prediction.
Have you determined the heat map?
It's we have might be so like it's in the I'll have to look for it actually, sir. I guess we haven't generated the heat map for this.
Okay, thank you.
Okay. Uh, morning. Good good morning, Mr. Sir Yash
Good morning,
Jaiswal.
sir.
Mm. Thank you for your comparative study on large language models versus classic metrics for software detect defect prediction. And my suggestion is that your future work could investigate hybrid models that combine LLMs, your large language models, with classic metrics to leverage the strength of both approaches. And I have this question. What are the key advantages and disadvantages of using large language models compared to traditional metrics for software defect prediction?
You see, when we are using these large language models, we are able to incorporate a lot of knowledge that is not being incorporated by traditional models. Like traditional models give us the structural complexity, give us the brief about how a program is structured, number of lines, number of methods, try-catch blocks, but it doesn't give us an insight to how the codes are written or how the actual control flow logic or the data flow logic is working in our program. Suppose if we are writing two programs for the same number of lines, person may use different approaches. Somebody can use loops, somebody can use recursions. When we use this LLM based model, it is able to better capture this data flow, control flow, and semantics. Also, but with the if we see when we use this large language model, it is really data hungry, and also it is at times unstable.
Okay. How could the performance of LLMs be improved for software defect prediction task?
Maybe so like for more improvement, we can actually fine tune our current model. Fine tuning will help it to generalize more better on our data set, as well as to more cross project studies will help us to evaluate more like if is it getting limited to our one language or one project, or is it like able to generalize across different projects?
Okay, thank you, Mr. Yas. Sir Yas, thank you.
Thank you, sir.
Mm.
Thank you so much, sir. Thank you, Yash. Can you please stop presenting? Yes. Moving forward, I would like to request Sir Bharat Stang to kindly present his paper titled Opportunity Lens, Automated Skill Assessment and Learning Optimization via Dynamic MCQ Generation. Sir, do we have you here with us?
Yes, ma'am. Is it audible to you?
Yes, sir, you're
Is
audible.
my screen visible to everyone?
Yes, sir, your screen
Okay.
is visible.
Good morning, everyone. Myself, Bharat Tank, working as an assistant professor at Palo University in the Department of Computer Science and Engineering Department. Along with me, my team is here: Malav Patel, Ayush Modi, and then we have the Mayur and Ayush over there as well. Now, our aim of the project title is, or the paper is, Opportunity Lens. This is like one kind of the AI development tools. With the help of that, we can find out the best of that particular career development tools. So this is just not beginning, but it is something big which we can do. Let's just start with our project abstraction. So the system core innovation lies in the dynamic generation of skill-based multiple choice MCQ systems over there as well. And this is will helpful for the different types of the competitive competition, and find out the basic skill of that particular persons over there as well. So employing a sophisticated language model framework to create contextual relevant questions and high definition restrictions over there as well. So performance is evaluated in real time to construct detailed user skills profile over there as well. And this mapping is facilitated the delivery of tailored career path and learning resource recommendation by enabling the adaptive testings and targeted interventions over there as well. So the opportunity lens streamline the professional development and significantly mitigate bias associated with traditional assessment methodology over there as well. Now, what is the main behind the motivation behind the research? So first one is learning capabilities we need to identify, because people have learning capability which they don't recognize due to absence of unfilled and learning platform over there as well. So we will provide one platform so with help for. Then second one is human-made manual assessment
Sir,
system. Yeah,
Professor, excuse me.
yeah, yeah.
Can you please put it in presentation mode?
Just 1 minute, sir. Yes. PPT. Yeah, sir. Now it is visible. It's full screen visible, sir.
Yeah, it's fine now.
Yeah,
Yes.
Yeah,
okay,
please
yeah,
continue. Please
okay, sir.
continue.
So motivation behind this, the learning capability, people have the learning capability which they don't recognize due to absence of unfilled end-to-end learning platform. Now, second one is the human-made manual assessment. So we can create our own assessment system which remove the manually. So take time for cannot be perfect for test and skills over there. So we can reduce the biasing as well. So that's the motivation behind. Then lack of lifelong learning as well, because lifelong lack of continuous learning platform we can get. Now our aim of the research is for accelerating professional growth, because to optimize the learning outcome by delivering tailored educational resource and adaptive assessment that target individual skill gaps over there as well. Second one is we can enhance the learning effectiveness, so streamline professional development through automated systems that identify career path and reduce the time required to manual skill assessment. Then we can bridge the gap between workforce skill as well, so to foster the high quality skill workforce by identifying hidden talent and mitigating the bias often, and adapting the rapid technology evolution as well, because nowadays we are having the different types of AI tools. Okay, so this is like one kind of AI development we can do, and based on that we can have. And now before we move into that, one of my teammate will give you some demonstration. Malo, can you please share your screen and give demonstration? We can just start with the demonstration. So what we have done, actually how it work. Okay, and then we'll go with our remaining. Hmm? Good. Continue.
So, hello, yes, yes. Can you start the demonstration? So, is my screen visible? Yes. Yes, sir. Yes, sir. Share. So, let me stop it.
Yes, your screen is visible.
Yes. So basically, this is the
It
UI of our platform. We have all the things here. We have signed in. So let's quickly dive into our assessment section where we can create assessment based on our topics. Like we have all the major topics and all the major subjects are listed here. So for demonstration, let us select uh, some of the topics. We can choose a difficulty level like easy, medium, and hard. We'll go with medium one, and then we will generate the assessment. So in backend, what it is doing, like these inputs and this proficiency level, it has been sent to our model in the backend, and then the model will generate its context for the particular subjects. Then it will generate distractors for the same to enhance the quality of the test which is going to be generated. So let us go and give a demo test for the same. Okay, so okay, this is the type of test interface which the basically the user will get. So let's quickly finish this and just okay. Okay, so now you have completed the test. So furtherly, now what are the assistants which we provide? Okay, so after giving the test, here we can we can see all our scores and thing, which how much we are progressing, and we have an AI learning assistant which will help us to refine our skills in which we are lacking. For example, if we want to create a personalized learning path, so we will click on generate, then it will generate a path basically. Okay, like that we have section wise all the topics arranged, and we have all the open source and free materials which we will use them to refine our skills and to study. And other than that, we also suggest some free courses from the internet like Udemy and Coursera for the specific topic in which you are lacking behind. So it will help to polish them of your skills. And the main feature is if you score more than 60 or 70%, you have an higher score, then you can unlock this area, which where basically opportunity scout. We have it that provides us the good first issues from the GitHub from all the open source projects, so that if you have a good score, then you can you can contribute to one of these according to your topics. We will the our platform will find good first issues on GitHub, and for the same you can contribute to that, and you can by the same you can also contribute to the open source, and it will help you to polish your skills. And this is the performance analytics which you will get after all the things. So yeah, that's the over to you, sir.
Thank you, Malav, for giving some basic demonstrations. Okay, so this is a particularly our main agenda behind development and testing of this particular. So why we need to go? Because our main aim research is fulfilled with demonstration. Why? Because learning and development statistics nowadays by till 2030, we have 59% employees will need upskilling and reskillings. Okay, so then right now currently today's market 39% bit out of dated and 78 million new job opportunity will be emerged. So these are some of the statistics we'll get it from the online source as well. To treat the skill as statistic currencies first, then connect the reskilling retention over there as well, balance digital scalability, invest in island functions over there as well, then move beyond the learner statistics. All these things are there, and these are the skill gaps which we have identified. Skill gaps employed in industries by hacker or art. So we can get in 9 in 10 responses say their organization either face skill gaps or already expect goals. Then 64% this particular professional said that reskilling of the current workforce will need to go. LinkedIn report as well. Then 8.5% $4 trillion conflict revenue over there, and 70% professionals say skills gaps in productive work over there as well. So these are the gaps we need to fulfill. Then these are the impact that we have already identified from the resources. These are some of the based on that we have. So what is the innovative research? We have AI-based skill assessment test which we have implemented here. So it leverages the AI to generate questions according to the user's field and of interest as well. Then we'll go for the advanced insightful based on the assessment given by users and learning database. Then learning pathway. So we'll get user provided by learning pathway according to the current job scan job recommendation system also do. So we'll give tailor and personal recommendations over there as well. And now this is our technical stuff that we have already implemented. So we can go for the Python, Express.js, then net, and then MongoDB is these are the technical stuff we have used in that particular things. This is a workflow chart we can have in this particular. So we can start then input skills to model, then convert input into the product tokens, generate database, then APIs, API call for database, user gives assessment, job mapping, and then finally it will stop over there as well. So these are some of the internal workflow how it works. So first whatever we have seen demo, the demo is explained here in this particular. So first we will start, then if it register, yes, if it is then login, if not then again it will come back. Once it is login, then input skill or difficulty it will identify, then based on that model process data generated test whether it is generated or not, then we'll have the question yes, then if no then again it will come out, then user gives assessment and then model evaluations and calculations code and then predicted career and then finally we code. So this is what internal activities architecture which we can have. So we can start with open applications, then already has account, then okay create account, if not then okay if it is email password you can create account, if not okay if it is then validate the credentials, all these basic stuffs which we need in any one of the online. Okay, that then it will career generated career assessment questions, yes, assessment dashboard is there, view assessment questions, submit the answers, then based on that we have process submissions, evaluate of AI models over there, then calculation career compatibilities, and then it will give some result over there, and then we can come out from that. So this is internal process which we have already implemented. Then these are the different class diagrams which we have already used. Users, then passwords, login based on that. Then we can create the questions. Okay, then we can generate contents over there, authentications over there as well. Then evaluation methods are there. So these are the theoretical part which we have already implemented inside our. Then opportunity lens level DFT context diagram. So we can have the first user, then login credentials, assign opportunity lens systems. This is our system which we have already developed. Okay, then we have different types of the model algorithm trends and then database over there as well. This is level 0. Then we have to level 1 again in second system. So we have users, then it will go for the first 0.0 or 1.0 user identity authentication process, then assessment generation, then question processing, then it will check D2 level as well, then process response processing as well, and then OL models generation over there as well. So through this step-by-step process, we have tested each and every models over there as well, and then finally we reach to that particular. So in this particular ER diagram, we also have users, then these are the login credential we have created, then questions generations, all this theory part we have explained all everything in that particular process over there. Then we have this is particular sequence key user is authentication services, question modules, answer modules, AI models over there as well, database over there as well. Okay, so all these things, database and all these things we have done, and the sequence diagram we have implemented. So to reduce some time, we have just gone through this particular process. So we can have case diagram as well. So we can log in, register, test, review, log out, and use cases we can do. And the database design we have done, user, then achievements, quiz, questions, different types of subtopic, chapters, learning path over there as well. And this all database we have already implemented in that particular things over there as well. So, and this is the dashboard which we have already shown through the demonstration as well. Okay, so we have implementation language, so empowering you to explore, learn, and growth, precision, statistic over there as well. So first, when they open, they will ask the same. This is a like we can log in with email, password, okay, and then once it is registered, then we get the welcome message over there as well. Then they log in over there as well. Then assessment center, so it will start from this part, and then we have. So this is a particular uh, database which is created, and then finally we'll get the result over there as well. So final score and all these things will get it over there as well. So first module 1 completed, module 3 completed, then candidate
This
skill
is a
audit we can
10-minute
do. Yeah, okay,
reminder.
we'll complete. Okay. Okay, so this is a particular resume screening test. Suppose the cloud architecture, Microsoft, which skills how we can identify for phase one. Then MCQ generation technique we have used. So flow of MCQ generations, topic conditions, contents generations, and how we can generate different types of. And then we have used initial assessment test. We can start from this. So first two, three, four, and then learning assessment, course recommendation systems, AI learning base we have. And then we can also test customized learning path. We already have this particular YouTube link and all these things we have used. Then you can also they can learn from this resource which is available. Okay, then they can apply for this particular like senior full scale development we have already created. So you can click over there and they can apply for this particular. Okay, these are some of the GitHub first issues which we already created. Okay, and result of assessment module we already seen. So here we have this particular trial 1, 2, 3, 4. Okay, and then particular results will get it over there as well. So what are the advantages of our system? So personalized assessment system, AI tailor career test to user skills, then dynamic question generation, no static question bank ensure, efficient career recommendations, and then we have scalability support multiple users, data-driven systems. These are some of the advantages. We have some limitations like complex AI processing here then. So implementing the adaptive assessment require high quality training data as well, continuous update needs over there as well. And the final conclusion is our automated assessment system. So opportunity lens can do automatic the creation and the evaluation of multiple choice questions. Then significant reducing time educations can do spend the test of preparation as well. Then we can facilitate personalized learning as well. So we have aim to provide the tailor assessment adaptive because nowadays it's many modules which is available. Okay, based on that we can develop. Then capability of making world better place. So to research has capability to foster better talent individual for every kind taking human as well. Then better job recommendation system it can do and adaptive technology evolution over there as well. Now in future we can go for the gamification interactive learning as well. Then predictive approximate future trends and VR based learning system we can also implement in this particular things over there as well. These are the resources of our implementation. Before implementation we gone through some of the papers which is available on IEEE conference proceeding as well. And based on that we have find out this particular
So you
latest.
have crossed the
Yes.
12-minute mark. Can you please conclude?
Okay, so these are some of the research literature view, and these are some of the references. Okay, yeah. So now session is open for the question answer if anyone will. Hello, can you please?
Thank you so much, sir.
Yeah.
Are there any questions?
Yeah, Professor Bharat, I
Yes.
just would like to know that first of all, complexity levels with regarding to questions is very important here.
Yes.
Yeah, if they adopt your model, they should be employable, one who use. So, may I know what is the logic for introducing complexity levels or increasing complexity levels in your model?
Yes. Malu.
So for logic, the logic of complexity levels is basically driving the context from the internet so that which is in the deep down of the internet, but it is also implementable in world because it is a skill-based career development platform. So the logic here remains as is that even if a old person doesn't shouldn't know the answer.
Okay, thank you.
Uh, good morning,
Yes.
Professor Bharat.
Yes. Sir, good morning.
Thank you for your presentation on this opportunity lens, automated skill assessment and learning optimization via dynamic multiple choice questions generation. So my suggestion is the same. You also consider incorporating adaptive testing methodologies to tailor the difficulty of the multiple choice questions to the individual learner's skill level. So I have two questions. Number one question is that how does the system ensure the quality and relevance of the dynamically generated multiple choice questions? And number two, what mechanisms are in place to prevent the system from generating biased or unfair questions? Sir.
Yeah. Malu.
Sir, so biases are by the system. They are usually by the people who are working corporate. And secondly, the bias issue can be ensured by making sure that there is no such So sometimes the model gets hallucinated and generates the questions which are not relevant to the topic. But that's why we choose and then approach like it generates a context for the particular topic first, and then using the whole knowledge base, it will generate the test or the quiz on the base of that, so that it doesn't get hallucinated or it generates something which is not related to the topic which we have selected to get.
And for the quality and relevance of the dynamically generated multiple choice questions, how do you ensure the quality and relevance?
So, sir, as far as the quality is concerned, for now we are using that context approach, but further we are trying to make a data set from these generated questions only, because we don't have any quality questions or like that thing. We have predefined questions on internet, but they are already used somewhere, they are already been asked. So the questions which are generated currently from this platform by the users, they will be used further as a data set and will be train the T5 transformer model which we are using at the back end, and to refine the skills more, refine the test more and more.
Okay. Thank you. Thank you.
Thank you, sir.
Thank you so much, sir.
Yes. Thank you, ma'am. Yeah.
Thank you. Next up, I would like to request Sir Kehinde Ovoy to kindly present his paper titled Towards Sustainable Transportation, a Framework for Intelligently Managing Traffic Roadkill Using Multitask Learning. Do we have you here with us, sir?
Yeah, sure. Can you all hear
Yes.
me? All right.
Yes.
Let me
Can
share
hear
my
you.
screen then. Yes, I can hear you.
I can also
Um,
see your screen,
can you see my screen?
but there's Zoom there. So can you just open your presentation?
Yeah, can you see my screen now because I've shared it?
Yes, yes, yes.
All right. So yeah, let's get started. So yeah, I'm Kehinde, and
So
I'll
wait, your Zoom screen is visible, your presentation is not visible.
just hold on then stop sharing. Can you see my screen now?
Yes. Yes, now your presentation screen is visible. Can you put it in slideshow?
All right.
Thank you. You can start.
Yeah, so yeah, I'm Kehinde away from the United Kingdom, and I will be giving this a brief talk on this topic. Towards sustainable transportation, a framework for intelligently managing traffic.
So you're not audible. Is he audible to anyone else? Because I cannot hear you.
No,
No,
no.
not audible.
Can you hear me now?
Yes, yes.
All right, yeah, so I've actually removed my earpiece. So yeah, I can start again. So yeah, I said reducing biodiversity loss is a critical component of the 2030 Sustainable Development Goals, right? So every year, hundreds of thousands, if not millions, of birds, animals, and general die globally in roadkill incidents involving interaction with transportation systems. So the idea is that to combat this problem, right, we really need an intelligent framework. And in this work, that's actually the focus of what you're trying to do. So we consider the problem of predicting roadkill incidents, yeah. And more importantly, we cast this problem as a multi-level binary classification problem. We propose an attention framework with a multitask learning to estimate roadkill incidents, and then using data sets of roadkill incidents involving 18 species, we demonstrate the effectiveness of the proposed approach. So, in terms of what has been done in the past, so several work has been done in the past to estimate peak roadkill intensity Work has been carried out to predict roadkill incidents just by segmenting roads to make things easier. And then there has been work carried out. We just focus on just the season. And basically, we try to address all these gaps. First of all, mainly by using gaps. Mainly by using a data set that contains incidents over multiple seasons and at a more finer granularity. So in this case, we have roadkill incidents at the at a more finer granularity of longitude and latitude. And then we use a framework, in this case, an attention framework with a multitask learning to be able to estimate roadkill incidents of multiple species at the same time. These are some of the things that have never been done in previous works. So again, just a bit of a background on the attention mechanism. So given an input as, for instance, you use a linear transformation of this input and a learnable projection matrix to generate the queries, keys, and the values. And then using the scale projection of the key queries and keys multiplied by the values over a softmax function, you're able to generate weights where the value of each weight corresponds to the importance of the variables in the input. So to get more, to make your model more expressive, I mean, you can actually concatenate more attention together to get to multi-head attention, and that's basically what we use there. Again, with the multitask learning, I mean, the idea of multitask is just to be able to improve the prediction of interest, the task of interest, by actually adding another task. So in this case, I mean, the main task is a multi-class, multi-label classification problem. But basically, what we've done is actually to add a regression problem. In this case, we use the most informative input feature as the auxiliary task here. And then overall, you have a loss function combining both a binary cross entropy loss objective and a regression loss objective together and optimized all together. So this is what the vector schema framework looks like. You have the scaled out attention fed into a linear layer, and then you have two final linear layers. One for the multi-level classification, and this is actually augmented by a regression task. So in terms of the data set here, so we use the data set here consisting of roadkill incidents for 18 species collected in Israel. This data set contains several environmental features, traffic volume, road attributes, and water view. So there are 58 main categories of features here. You have the coordinates, which is the longitude and latitude. You have the road lightning, joining unpaved road, drainage, parallel road, lots of them, maximum speed limit, range which is per kilometer. Roadkill incident and a host of other features, but I think there are just about 58 of them, and I think there are about 18, almost 19,000 instances recorded at different locations across the country. Just three main things, experiments. So we calculated computed the correlation coefficient between each feature and the roadkill incidents for the 18 species and average all of them together. We compare the proposed attention framework with multitask learning approach with baselines in the literature. And then we use the area under curve to measure model performance. So in terms of the baselines, in the literature, you have basic ones like average random forest, added ridge classifier, and you also put vector machine, maximum entropy. We introduced deep neural network, and then we use the baseline vanilla attention here, which is actually a scaled out attention. So in terms of the results, so for the correlation coefficients, I've actually listed the top 10 features there. So as you can see, the range of visits per kilometer seems to be the most correlated feature with the roadkill incidents. But yeah, there are other features like the mean habitat suitability for each species, as well as the grassland cover and the longitude. And for the model performance, so as you can see, the proposed approach appears to be outperforming most of the baselines consider, as you can see that the multitask framework that is able to marginally improve performance with respect to the one without it, just a bit slightly, yeah. And then in conclusion, so reducing biodiversity loss via roadkill is a very important task towards achieving some of the biodiversity loss goals for the 2030 SDGs. And basically, we've actually introduced a multitask approach leveraging attention network to tackle this problem. The comparison with other methods in the literature shows superiority of the proposed approach. And then in the future, of course, we've considered just one data set here because of the nature of the granularity of the data set. The future will definitely add more, and then incorporate more more expressive characteristics of the animals involved in the roadkill incidents. Yeah. But yeah, I think that's basically everything. I don't know if anyone has got questions. I'm happy to answer them.
Okay. Good morning, Mr. Kehendi. Thank you
Yeah.
for your presentation on the framework for intelligently managing traffic roadkill using multitask learning. And I have the suggestion it would be also be valuable to explore also the ethical considerations of using AI in wildlife management and conservation. Just like to your now I have two questions. How does the multitask learning approach improve the accuracy and efficiency of roadkill detection and management compared to single task models? And the number two question is that what are the practical challenges of deploying this framework in a real world transportation system?
Yeah, thanks very much for those two questions. So maybe I should start with the last question. So in terms of deployment, there will be a couple of challenges in terms of model complexity. I mean, attention models generally are really complex. So that's one thing that will be considered if we're gonna deploy this in practice. Yeah, but I'm pretty sure there are ways to actually get around this. And then to the first question, right? So we did compare this, right? So I compared the model with an attention network without an auxiliary task, right? Without a multitask learning, and as you can see in the result, it just marginally improved. Adding like a multitask framework marginally improved the performance of the model, then by just 1% or thereabout. Yeah, so that did really work. Yeah.
Okay, thank you. Thank
Thank you.
you.
Yeah, Mr. K, in the proposal, the concept, whatever you have presented, shows concerns to species in, of our environment, nature. My question to you is there any digital solution to avoid road kills? Maybe a takeaway question.
Sorry, I didn't get that. What's the question? Can you repeat your question?
Sorry?
Can you repeat your question?
Okay. Is there any digital solution to avoid roadkill from your perspective?
I mean, so, I mean, apart from the framework, the computational methods we have proposed, there can be some other ways to avoid these. It could be, I mean, sometimes, I mean, the idea is to incorporate this in navigation apps in the future. I mean, that's the goal. I mean, if you can be in a position where you can actually warn people on major roads or minor roads about the probability of experiencing a roll kill. I mean, that can actually help. So, I mean, the end goal of this is just to get this into navigation apps and then just provide more warning to drivers in the future, just to be a bit more careful around places, by just telling them the kind of animals they are just going to see in that kind of environment. So yeah, but that's just the goal. Yeah.
Yeah, okay, I got it.
Yeah.
And also you mentioned about estimating insect skill. How is that possible logically?
Estimating what?
No, estimating roadkill of insects.
Incidents, yeah. I mean, the incidents. I mean, so these things have been logged manually, right? So human beings have actually, volunteers have actually logged some of these things. Yeah, I mean, I understand that. Yeah, those things can be too super small. But in this particular data set, I don't think there are insects there. I think they are really vertebrates, big animals. Because logging death of incidents via death of insects via roadkill can be a very difficult thing to do. So yeah, but this particular data set just contain big animals, not insects. But I mean, in reality, yeah, insects die as well via roadkills, but maybe it's not as obvious as the big animals. Yeah. So yeah.
Okay, thank you, thank you.
Thank you.
Thank you,
Uh, am
sir.
I am I still sharing my screen?
No, you're not sharing the screen. It's fine.
All right. Yeah, that's fine.
Thank you so much.
Thanks.
Moving forward, I would like to request Ma'am Ananti Mule to kindly present her paper titled Per Pixel Adversarial Perturbations for Proactive Deepfake Defense. Do we have you here with us, ma'am?
Hi. Yes. Yes.
Yeah, you're audible. Just give me a second.
Yeah.
Yes.
Okay, I'll just share my screen.
Your voice is very low.
Oh, is it better now?
Yeah.
Oh, yeah. I also have my co-authors, Gargi and Shruti.
All right. Will all three of you be presenting together or only one person?
Yeah. We'll be presenting it together.
Okay, whenever you guys take over, please introduce yourself.
Yeah, definitely.
All right. Yes, your screen is visible. You may start.
Okay, thank you.
Hello, am I audible?
Yes, you are, Gargi.
Yes, okay. So, greetings to everyone, respected members of the board, distinguished panelists, and all the attendees joining us through the Zoom call. We'll be walking you through our research titled Per Pixel Adversarial Perturbations for Proactive Deepfake Defense. This work has been carried out in collaboration with my teammates Ananti Mune and Shruti Kulkarni under the guidance of Dr. Anjali Nayak. With deepfakes becoming increasingly realistic and widespread, our work focuses on a preventive defense strategy that intervenes
Madam,
early.
excuse me, can you be a bit louder volume?
Yeah, sure. So, with deepfakes becoming increasingly realistic and widespread, our work focuses on a preventive defense strategy that intervenes early in the generation pipeline rather than relying solely on post generation detection. Next slide, please. So this is our agenda for today. To give you a brief overview, we will begin by discussing the background and motivation behind the need for deepfake defense. We'll move directly to our proposed methodology where we explain the overall system architecture and the detailed processing pipeline. And finally, we'll present the experimental results and comparative analysis, which demonstrate the effectiveness of our approach in terms of both visual fidelity and deepfake disruption, and also in comparison with other models. Next slide, please. So, deepfake technology has evolved rapidly due to advances in generative models such as generative adversarial networks or GANs and other diffusion based architectures. So, these models can now synthesize facial images and videos that are extremely close to real human appearances. And while such advancements enable positive applications in media and entertainment, they also introduce serious societal risks. Deepfakes are increasingly being misused for identity impersonation, misinformation campaigns, reputational attacks, and digital harassment. Most existing defense mechanisms attempt to detect deepfakes after they have already been created. However, as generation techniques continue to improve, detection based approaches struggle to remain reliable and scalable. So, we have taken a different approach in our work. We are trying to be the stitching time. So instead of detecting manipulated content after the generation, we aim to disrupt the deepfake creation process itself, particularly at the facial landmark extraction stage, which we will be explaining further, and that plays a critical role in producing realistic synthetic faces. So over to you, Ananti.
Yeah, thanks, Gargi. So, four main reasons why this problem needs immediate attention is first that the deepfakes go undetected and they lead to misuse and impersonation, which is a real life legal and social consequences. Second is deepfakes can spread misinformation at a massive scale when it comes to any political agendas or any crisis situation. Third is people can be targeted with harassment, reputational damage, and emotional distress as well. Finally, deepfakes get better uh, society and because it makes the people trust in the digital media more and help them not lose trust. And developing a reliable and early stage defense mechanism is extremely important. Our objective is pretty straightforward but challenging at the same time. We aim at designing a perturbation based defense that makes it difficult for deepfake models to generate realistic manipulations while still ensuring that the image looks completely normal to the human viewer. So our goal breaks down into three main checkpoints. First being adding a small pixel level change that is strategic and not random. Second, ensuring that the changes actually disrupt the deepfake pipeline, especially in the facial landmark extraction step. Third is making sure that the image still looks perfectly natural and the protection is invisible to the user. Over to you, Shruti.
Hello, am I audible?
Yes, you are.
Yes, so now moving on to the literature review. We have reviewed 40 papers that cover adversarial attacks, watermarking, and deepfake detection. These are some of the key takeaways from this review. The landmark breaker plus plus uses adversarial noise but doesn't have any cryptographic control. TSFFnet and Deep Feature XSN are accurate detectors, but they don't prevent deepfake generation. They just classify it afterward. So their mechanism is reactive, not proactive. Methods like dual defense, ID guard found, and lead introduce universal or latent perturbations, but they don't use per pixel key based noise, which limits the security of the image. Watermarking techniques such as RSA based watermarks or LSB steganography are good for tamper detection, but they are not good enough for breaking the deepfake pipeline. So the gap is clear. No existing work combines per pixel key based perturbation, cryptographic hashing, adversarial robustness, and high imperceptibility in the way that we propose. Next slide, please.
So, our proposed methodology is designed as a lightweight image level defense framework. The system architecture consists of 5 tightly integrated stages: per pixel adversarial perturbation generation, adversarial optimization, dynamic watermarking, steganography, and the key management. Each stage contributes to ensuring that the protected image remains visually natural to human observers while significantly degrading the ability of deepfake models to extract meaningful facial features. So, when an image is uploaded, it is first classified to verify whether it is a real image or a deepfake image. Once verified, the image enters the protection phase. During this phase, cryptographic techniques are used to generate dynamic per image perturbations supported by secure key management. They are embedded directly into the image using steganographic principles, ensuring that the changes remain invisible to human viewers. The protected image can be safely stored or shared. If the image is passed through the deepfake detector again and there are no visual differences in the original image as well as the protected image, the image can be given to the users for safe use. If the image is categorized as having some differences, then it is passed through the loop again for further iterations for improvement. Next slide, please. So, suppose this image has been given as an input to the users. It is firstly converted into a black and white pixel representation for, for optimization. We begin with an input image, then a per pixel perturbation is applied using an SH8256 based cryptographic key. It is performed on a pretend ResNet 18 model. And this step refines the perturbation so that the feature extraction mechanisms used by the deepfake generators become unstable and unreliable. We then evaluate robustness under the JPEG compression to stimulate real world image sharing scenarios on social media platforms. The red arrows in the images show the point where there are the greater chances of deepfake attack, and we are trying to pinpoint those, we are trying to extract those stages and apply our mechanisms on those stages so that the image can be protected. After the phase 1 and phase 2 mechanisms are applied on the image is again converted into a colored format and given back to the user, and this completes both the phases of the deepfake prevention mechanism. So the results. Our method achieves an LPIPS score of 0.0044, which is significantly lower than methods such as anti-forgery, lava, zodiac, and baseline perturbations. So LPIPS is a metric which signifies that lower the metric, higher perceptual similarity is suggested, meaning that the protected image remains visually close to the original. While other methods demonstrate robustness, they often introduce noticeable distortion or they lack pixel level key based security. So, in contrast, our approach achieves a strong deepfake disruption while maintaining superior visual quality. LPIPS was the metric which was chosen by us because the learned perceptual image patch similarity is something that is a library of computer vision, and it gives us the metric of how similar would that image look to the human in the loop. Instead of just having a metric on the paper, we try to keep the human in the loop and understand from that point of view. So overall, these results demonstrate that our method provides an effective balance between perceptibility and defense strength. So it is well suited for practical deployment. In the next slide, my friend will also introduce other parameters that we tested these models on.
So here we can see that we have represented the results in a visual format. In the first plot, the left-hand side plot, when we compare our method to previous works like anti-forgery, lava is latent watermarking, and zodiac, that is a diffusion-based model. So when we compare our results with them, we realize that our LPIPS values, which represent visual similarity, are much lower, meaning our approach maintains the highest image quality. At the same time, our method still disrupts synthesis more effectively than the prior techniques. The analysis for the deepfake prevention, we have done the analysis on based on various types of attacks like brightness, contrast, noise, and rotation. The right-hand side figure demonstrates the robustness imperceptibility characteristics of the proposed watermarking under these various attacks. So the detection correlation remains consistently above the threshold value, uh, resulting in a high overall detection success rate of 94.4%. At the same time, image quality is largely preserved as indicated by the favorable PSNR values across the common post-processing operation. The quality detection trade-off analysis further shows that high perceptual quality and reliable watermark detection are simultaneously achievable, with degradation occurring only under extreme conditions. Next slide, please. So here we can see that the first is the original image, second is the original image with the embedded watermark, and the third image is the original image minus the watermark. So in this slide, we have highlighted that even though our watermark is imperceivable to the human eye, it has been embedded in the original image, and we have reverse engineered the process and done some pre-processing to show that there is actually, I mean, the watermark is then visible in this difference that we can see. So the difference is basically the original image minus the watermark. Next slide, please.
Okay, to summarize the key highlights, we propose a defense that acts before the deepfake is even generated.
There's a
By
gentle
modifying,
10-minute reminder.
yeah, sure. So by modifying the pixel intensities using SHA-256 based key refining adversarial optimization, we try to break the defense pipeline early on. So that's how we achieve robustness, and also perceptual distortion can be minimized. And it is also a model a agnostic behavior. So that's the reason defense rate, success rate is absolutely high. The future scope in our case includes being able to also accommodate video deepfakes, which also embed some audios as well. Because in this domain, cross-domain deepfake defense is absolutely important, wherein we are also able to analyze audio deepfakes. So these are would definitely be one of our future scopes. And the second important future scope is being able to embed this directly into camera hardware or firmware, so that the images are protected right at the moment of capture. So these are a few future scopes which we would like to highlight. Secondly, at the end, we would like to thank Anjali Nayak ma'am for her support and guidance. And thank you for listening. And we're looking forward to your questions. Thank you.
Yeah. Uh, uh, I guess you are all students,
Yeah.
and is this implemented? This concept?
Yes.
Yeah.
Okay, good. It seems a good work. I just want to ask one question there. You have mentioned about steganography, and what is
Yes.
the role of steganography in this particular overall system or framework? And what is the amount of bit of information you are embedding in each pixel as far as steganography is concerned? I would like to know this.
Okay, Garki, would you like to take up that question?
Yes. So basically, sir, what distinguishes our approach from all the other
Please
approaches?
be louder. I am not able to hear you. I can hear others
Yeah, yeah.
clearly.
Am I audible now?
Yeah. Please
Yes.
continue.
Okay. Hello. So, what distinguishes our approach from others' approach is that the steganographic techniques that you've asked specifically, they are applied to per pixel instead of a part of pixels from the entire images. So, what happens basically is that when the steganographic principles are applied on the layers of pixels, those get embedded with an encryption key, and that encryption key gets stored into the database, which can be decrypted further on. So that is what we are doing currently, and we are also trying to reduce the size of the or we are trying to reduce the size of the payload so that it would be better for further optimization when it gets stored into the database.
And
Right. And the
also,
whole idea, I think, is about we're trying to disrupt the CNN learning process. So in the CNN, when an image is fed, we're trying to make sure that that CNN model does not learn properly from the image which we have created, so that the deepfake cannot be made out of that. So these watermark. So we're trying basically steganography is embedding some text in the image in such a way that it is not visible to the naked eye. So that's the reason it might look like a normal image, but it is a watermarked image and it is embedded with steganography. So that's the reason the model cannot learn from it properly, and thus it cannot generate a deep fake from it, thus
and
protecting
also
it.
in
Yeah.
one of your slides, you have shown two images, one original and another one is watermarked. And it was surprising
Yeah.
to me that the watermarked image is having more clarity resolution than the original one. May I know the reason behind this, or is my observation is wrong?
I think the watermark one was a little blur because there was also the watermark which was embedded. And the original one, I think, was clearer, right? If Shruti and Gargi could hop in and answer that. But I think the one with the watermark was a little blur than
Yes,
the
yes.
original one.
Difference. The difference in those images is the third image which is there. So definitely we know that the image that we are going to provide as an output is not going to be as clear as the original image, but we are trying our level best to provide the output in such a way that it is not perceptible to a human eye. But surely the image that we provide as an output has a bit lesser resolution than the ones that we have uploaded initially.
Yes. So how
Okay.
we do this process is whether we convert the image into a grayscale image and then we embed the watermark in it. So the watermarked image is basically more blur than the, but then we are, yeah, it's good to know that if the watermarked image it is the imperceptible. So that's like we have achieved a good result.
Yeah, that was the whole goal actually, being not able to tell that if that image is watermarked or not.
Okay, overall good work, and I wish you could make it a product and get into make it as embedded system in Android and iPhone as early as possible, because we are all facing these deepfakes too much.
Yeah.
Just cross the
Yes.
limit.
Yeah,
Thank you.
that is
Thank you.
true.
for the advice.
Yes. Thank you so much.
Okay. Hello.
Hi.
Good afternoon. Deepfake technology is constantly evolving, and thank you for this
Mhm.
presentation. How adaptable and resilient is your perturbation or your project defense mechanism against future, more sophisticated deepfake techniques, and what are the potential resource implications for maintaining its effectiveness over time in sustainable manner?
Yes.
Okay. So I think sustainability is all about starting early on as well, so that you're kind of minimizing the waste which is getting generated later. So here we are just trying to curb the problem right at the source. So as Nishchay Kumar sir also mentioned that it would be great if we could embed it directly into our cell phones, so that at the moment of capture only we're trying to protect that image. So that also helps in being more sustainable, as in we're not giving the chance to the hacker to create a deep fake out of it. So I think this is how sustainability we can take into picture, that is starting early on and making sure that we're protecting it right at the root cause. And I think utilizing resources, etc., is also one of our future scope, that is being resilient to cropping or resizing of the images. So that is definitely one of the future scopes which we would definitely like to work on.
And to add on to the answer for this question, as you mentioned, there are other companies which are trying to do something in this domain for early prevention and detection of the deep fakes. But what we are proposing over here is a middleware software that would be embedded in the middleware layers. So there is no specific front end, there is just a back end to our system. And we are eagerly looking forward to collaborating with these companies and launch it as a product.
That's good. Nice. Okay. So looking forward for that future endeavors of you. Good
Thank
luck.
you.
Thank you.
Thank you.
Thank
Thank you
you.
so much, Julius. Thanks.
Thank you.
Thank you so much, everyone. Thank you, sir. Moving forward, I would like to call again Sir Fauzan Fadlullah to kindly present his paper titled AI Enhanced Readiness, Assessing Customer Experience Management in Indonesian MSMEs through the Technology Readiness Index. Do we have you here with us, sir? Is anyone else from the team present? Okay, since no one is responding, I'll move forward. I would like to call again Ma'am Supriya Narad to present her paper titled AI-Driven Optimization, Fast and Scalable Data Retrieval in Big Data Storage. Do we have you here with us, ma'am?
Yes, ma'am, I am here.
All right.
Thank you.
Yes, ma'am. Can you please share your screen?
Yes, ma'am.
Yes,
Yes.
it's visible. Can you put
Yeah.
it in slideshow mode?
Yeah. Is it visible, ma'am?
Yes, it's visible. I request you to kindly turn on your camera as well,
Yeah.
and then you can start.
Okay. Yeah, ma'am. Thank you for the opportunity. Good morning, respected judges. I am Ms. Supriya Narat, and my co-authors are Chetan and Ms. Pranjali. And my paper ID is 241. Paper title is AI-driven optimization, fast and scalable data retrieval in big data storage. These are the contents. So in the age of digital transformation, like wherever we are having some expansion of big data also, like today we can see it's a era where big data is tremendously used. The lot of data is available on user side as well as on the cloud side also. So the term that is big data is presented and it is a great challenge to effectively store that data also, and as well as how to retrieve that data, because not only we are storing the data but also we have to retrieve that data back from that storage. So there are some conventional databases, like we are using a DBMS, that is called as database management system, which is available at our side, but we are unable to manage the mounting of data in terms of volume, velocity, and variety of data. Like in terms of volume, I can say a large amount of data is available, so it is already voluminous. Then velocity for processing, speed, etc., for accessing the data, and variety, as there is a type of data available in terms of files or pages, we can say, in terms of bits, bytes, images, videos, everything that comes from varied sources like IoT devices, social media, enterprise applications, as well as real-time analytics platforms also. So there are different platforms from where the data is collected every day. Now, while the companies rely more and more on big data storages, like there is a technology that is called as Hadoop. So from the year 2015, it is widely used in companies, because before that also Hadoop was evolved, but from 2015 it is widely used in various companies for managing the data as well as big data. Then Apache Spark is there, then cloud-based various platforms are also there. Now it has become critical to minimize the data access mechanisms in order to provide low latency, high throughput, and scalable data access to large data sets. So whenever I am processing with large data set, it may be from any field, it may be from management or some healthcare data, or it may be from any business also. So it will not scalable to access that data. Now there are some AI methods also available that can optimize indexing, caching of data. So how I can provide the indexes to the data, because the data is available, but how to save, how to provide the indexes for accessing, caching. So for some time also I want to store the data at storages, and query processing automatically. So when I am processing each and every query in terms of DBMS, so it will use the strength of deep learning, reinforcement learning, and predictive analytics, because right now I am processing that data with AI based methods available. So I can use any type of deep learning algorithms or reinforcement learning algorithms based upon the availability. Now, what is the purpose of this analysis? So the research that I am doing on this is to examine the capacity of AI optimization algorithm, because the DBMS technique is right now available. Then we are having some data analytics techniques also. Again, we can use AI not only for processing but for optimization. So my aim is not to only process, but how we can optimize the data which is already available in big data storages, and improve the data retrieval efficiency and scalability in big data storage systems also. Now there are some conventional query processing and indexing techniques also, like they gives you high latency, low adaptability, and inefficiency when dealing with enormous amount of data also. So through the integration of machine learning, ML, and artificial intelligence, AI, in data retrieval, this research aims to present a smart auto-optimizing framework that has the ability to dynamically respond to changing the data access patterns. So I'm implementing this auto optimization framework. That is, the data will be automatically processed, optimized using this framework, and it will have ability to dynamically respond to changing data access patterns also. Like sometimes I am accessing the data in terms of files, sometimes in terms of graphs or images or videos, etc. And it will enhance the data retrieval performance as well as the system speed as well. Now, this is one of the architecture that we can say it is a type of data retrieval and integration type of architecture. So in the bottom line, I have designed some databases, like it can be a SQL database or no SQL database. So in terms of SQL database, it can be a DBMS system. In terms of NoSQL database, it can be Hadoop or MongoDB or any other NoSQL database also. And there are some flat files who are storing the data, who are contributing to the data. Now there are some services which are connected with our DBMS databases or NoSQL databases. Those services can be used to access the data, to retrieve the data, etc. We can say. Now at the next level, we are using the integration service. that integration service can be acted like a middleware that is in between the user and the DBMS server. So this middleware is responsible for integrating the data which is collected from various sources, as well as we have to provide here some services. It may be like security, it may be like discovery of data, or it may be like registering a new data into the data warehouse or into the database. So in this middleware, we have to provide all these integration services. Then at the upper side, we can see that there is a user. So user will be accessible, will be responsible to access the data at the bottom side, that is at the SQL database. So the user will send the request as well as response messages, and in terms of response, the user will get the required results also. So the complete architecture which is available for data retrieval as well as integration, we can say. But now we have to again enhance this model by using the deep learning. Then we can find out some pattern detection or reinforcement learning mechanisms also. Then I want to discuss here about the review of published works also. So in the year of 2024, the research area is big data analytics. And in this paper, a comprehensive review of 15 years of big data research is highlighted with AI/ML as pivotal in addressing challenges related to data storage and retrieval. This study emphasizes evolution of big data as a cornerstone in AI and ML applications. Then in the year 2024, there is cloud optimization. Research has been done on cloud optimization also. This literature review delves into AI-driven approaches for optimizing cloud services, focusing on enhancing efficiency, scalability, and performance. It also discusses integration of AI in cloud infrastructures to improve data retrieval processes. Then in the year 2024, big data management engineering is done with research on again engineering processes. So in depth analysis of big data management, then exploring data collection, storage, processing, analysis, and visualization is done. This paper discusses AI's role in transforming data retrieval and management practices as well. Then in the year 2023, the research on AI in storage systems is done. So the analysis of AI and its use in storage system, that is how we can use again AI with storages, that tackles issues with dependability and performance. The study emphasizes how AI may improve data retrieval and solve complicated storage problems. Then research on big data based robust predictive analytics, that is memory and uh, computationally efficient. And this paper also covers techniques related to how to improve the data retrieval and storage efficiency, we can say. Then in 2023, predictive analytics research has been done on it also. So it is an article again which explains how the rapid development of AI that calls for a change in the technology infrastructure and again data storage and retrieval. Then in the year again 23, AI and tech infrastructures were used for effective information systems in order to satisfy AI's data requirements. Then there is traditional versus AI-driven data retrieval technique also. So there are some aspects of traditional techniques. So whatever traditional techniques we have used up till now, like the first aspect is indexing and search. So in the traditional methods, they have used like B trees, hashing, then inverted indexing with fixed structure as well as other methods. But right now we are using some adaptive indexing techniques or vectors. The vectors like search models, for example, FAISS model for dynamic optimization. So I have find out this technique in one of the research paper. Then for query optimization, we have relied on SQL based optimizations and rule based execution plans. Then nowadays it uses machine learning as we are optimizing the query with AI technologies also. So it uses machine learning for predictive query optimization and reducing the execution time. Then next there is storage and organization. So it uses fixed schema based relational models, making updates difficult. So right now the same AI based automated tired storages, then predictive caching and duplication improve efficiency methods are used. Then for handling unstructured data, it struggles traditionally with unstructured data. So what happened that whatever data is available, that data was unstructured data. So we have to pre-process, we had to process it properly for converting unstructured into structured data. Right now we are having some AI methods, deep learning methods, as well as NLP. So the data can be classified. We can provide the tags, names, labels, and retrieve the text, images, and videos automatically from that data. Then there is performance and scalability also. So
This is a
performance
gentle 10
degrades.
minutes reminder.
Yeah, okay. So there is a performance degrade with large data sets that requires manual tuning. Then there is fault tolerance as well as cost efficiency. So with traditional methods, we have tried to improve it, but right now with AI-based method, we can handle it efficiently for storage architecture, then detect and fix error autonomously, as well as it helps to reuse the resources, then reducing cost with automated storage allocation. Then there are some challenges as well as limitations also of AI-based data retrieval, because as it is a technology, there can be the challenges whenever we are retrieving the data. So AI-driven data retrieval faces several challenges and limitations like scalability and reliability. So the first challenge that I am discussing here is the high computational cost. So AI-driven retrieval systems need enormous computational power for training, indexing, and query optimization, as well as there are some deep learning models like vectors we can use other neural networks that need high performance GPUs as well as TPUs, so which raises the cost of infrastructure. So whatever infrastructure we are creating, it should be optimized not only in terms of space or processing, but in terms of cost also it has to optimize. Then organizations need to find a balance between performance and cost effectiveness while deploying AI driven solutions. Then there is data privacy and security risk, like AI-based retrieval entails processing large-scale sensitive data such as personal, financial, and healthcare data as well. So I'm concluding now. The investigation of AI optimization for quick and scalable data retrieval in big data storage. It emphasizes how revolutionary machine learning (MLs) and artificial intelligence are in overcoming the drawbacks of conventional data retrieval techniques. As well as this study shows how AI optimized methods like dynamic query optimization, adaptive indexing, and predictive caching greatly increase the scalability, efficiency, and speed of data retrieval in large-scale storage systems. Then the research demonstrates that AI improves query performance by learning from historical data, anticipating access patterns, and adaptively altering storage structures through thorough comparison of traditional and AI-based retrieval strategies. So these are the references. I have tried to use some recent references here. Thank you very much for this opportunity.
Madam,
Yes, sir.
you were stressing upon this one, data optimization. In
Yes,
fact,
sir.
data optimization, the main point over there is data retrieval.
Yeah.
And you have mentioned already about the B trees, hashing
Yeah.
technologies and all.
Yes, sir.
Why didn't you cross verify the same with B trees, sorry, not B trees, red black trees and AVL trees? Or can you
Yes,
just
sir.
give me
Yeah.
more details on that?
Yeah, I can explain, sir. So, sir, the data structures are already available, and it is a ancient method. We can say it is a traditional method, but it is again a best of best method which is available already. But when we are approaching towards AI, so we have to move from the AVL trees available in data structure towards B trees, B plus trees, as well as the decision trees available in machine learnings right now, because we are going towards AI. We have to implement the structures and algorithms in AI. That is why, sir, I am discussing about all those recent approaches available, because in detail, again, we can go. It is again a good question, sir. So I will try to elaborate those terminologies also next time.
Yeah, because from the studies it is said that red black trees and AVL trees are very efficient compared to
Yes,
other kind of trees.
yes, sir, yes, sir. Yes, I will try to compare
Okay,
them also,
you
sir.
can
Yeah,
take it as a suggestion from my side for your
yeah,
future works.
yeah, sure. Yeah, thank you very much, sir, for suggestion.
Thank you. Thank you.
Yeah.
Hello, Miss Supriya
Yes,
Narad.
sir. Yes,
Good
sir.
afternoon. Thank you for your presentation on AI-driven optimization for fast and scalable data retrieval in big data storage. So very relevant in today's data-heavy storage. I have two questions. How does your AI-driven optimization compare to traditional database indexing methods in terms of performance and scalability? And the second question is, what types of big data storage systems are best suited for your proposed optimization techniques?
Yeah, okay, sir. I want to give answer to your second question first. Like for big data storages, we are having Hadoop as well as we are having MongoDB also. So both the techniques are very good techniques. Like I have told you that in the year 2015, we have started with Hadoop implementation. After that, Hadoop was used in every IT industry. But right now, Hadoop is also again replaced by MongoDB as well as new data sources, because again the number of data which is available, that is again going to increase day by day. And that's why no SQL techniques are many techniques. There are many techniques like no SQL, MongoDB also. So I can say that for handling the big data storages, we can use Hadoop as well as MongoDB both. And sir, for your first question, when we are comparing the traditional techniques as well as the techniques available right now, so the gap or the difference can be created like optimization. So the data optimization was not done properly in the traditional methods, because yes, we have used many algorithms that time also. But right now, when we are using machine learning algorithms, so optimization is very fast in terms of space as well as speed. So I think the recent methodologies which are available, that are more advantageous rather than the traditional methods. Well, this is my opinion.
Okay, I agree. Thank you.
Yeah,
Thank you,
thank you
Miss
very much, sir.
Priya
Yeah, thank
Narad.
you for this opportunity.
Thank you.
Thank you so much, ma'am. Thank you, sir. And with that, we have come to an end of this session. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this version of the conference, and we'll be happy to have you in the next version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of MCT4SD 2025. I would also like to thank our session chairs, Sir Julius Serrano and Sir Nishchay Kumar Hegde. Thank you so much to both of you for joining us for sharing this session. Here's a small token of appreciation from the team of Global Knowledge Research Foundation and partners. I request you both to share a note before I end the session. Either of you can go first.
Okay. Thank you to all of our presenters for your insightful and thought-provoking contributions. We covered a wide range of topics showcasing the potentials of machine learning and computing technologies to drive sustainable development. And I would also like to thank my co-chair, Professor Nishai Kumar
Kumar
Hegde.
Hegde.
And also, I would also like to thank MCT4SD and the organizers for giving me this opportunity to co-chair the session. And thank you, Miss Professor Priyashi Goyal, for this opportunity. Thank you.
Thank you so much, sir, for your kind words. Yes, Nishya, sir.
Yeah, it was a really wonderful session. Presentations or the concepts that were presented were very well, and lot of information in terms of knowledge got transferred into me, or I believe the same with Julius sir, so that we can carry out our future research works in a proper way. So, and that's what I would like to thank, first of all, Dr. Amit Joshi, who is the conference chair, whom I met some years back. Also, I thank the entire team of MCT4SD, and I thank Priyanshi Goyal, madam, and I thank everybody. That's it. Thank you.
Thank you so much, sir. Thank you for your valuable presence. And at last, I would like to request everyone to please switch on their cameras for a quick snapshot of the session before we conclude the session. Can everyone please turn on their cameras? All right. I think I'll take the snapshot now. All right. Okay. 1, 2, 3. Thank you so much, everyone. It was wonderful having you. See you again in the next session. Bye bye.
Thank you.
Thank you. Bye.